Dear students, in the previous class I have taken on a sample example. I have explained how to construct a regression equation. In this class I will explain what is the meaning of coefficient of determination and test statistical hypothesis and construct confidence interval on regression model parameters. There are one parameter is the b, the coefficient of x is one parameter. Now I will explain what is the goodness of it, that is coefficient of determination r square. Assume that y value. Assume that there is no independent variable. The easiest way for prediction is mean of the y. What is the meaning of there is no independent variable? Suppose I have demand for say first 11 month. I want to predict in 12th month what is the demand of a particular product. The easiest way is you find the mean of the previous data. So, that will be used as the mean for the next data. So, without considering any independent variable. Suppose if there is no independent variable, so the actual point is say this is the y is the actual value. So, the one way to predict without any independent variable is say y bar. But I know there is a one independent variable. What is this much? This is actual, this is predicted. So, this much is my error. What is this error? This point to this point, this is error. What is error? Total error, we can say total error, actual minus predicted. Suppose if I know one independent variable that I have, as I am assuming that is affecting my dependent variable, then that regression equation is like this. So, this I am writing y hat equal to, you can call it as b0 plus b1 x. Now, what has happened? Now, this much distance, because this point, so this much distance is, see total error is this much. So, this much error is, I could have written this way. So, here what is this much portion. This much portion I am able to explain with the help of regression independent variable. So, total error is this point to this point. So, this much error with the help of independent variable x I am able to explain. So, the remaining error this much distance is unexplained error. So, what I am saying, this is only one point, there is no linear relationship. Like that there will be different y values, maybe y here, y may be here, y may be here, y may be here, y may be here. So, if I find the total sum of square, that is a total error, that nothing but SST. Okay. So, SST equal to SSR plus SSE. What is the SST? Total sum of square. What is SSR? Regression sum of square. What is SSE? Error sum of square. So, now what is the logic behind this is the total error is this point to this point, total error. I am splitting that error due to how much error we are able to explain with the help of this independent variable x, that is SSR. So, the remaining portions, that is which is in the bracket, that is unexplained error. When you look at this, there will be a connection with ANOVA. In ANOVA, what you have written, the same thing. In ANOVA, what you have written, SST equal to SS treatment plus SSE. Here treatment is nothing but your independent variable. Okay. Now, we will find out what is the formula of this. So, what is SST? So, this point is y, the total error y minus this point is y bar whole square sigma, that is SST equal to. So, this much portion, what is the error is y hat minus y bar whole square sigma plus SSE, unexplained error. What is unexplained error? Y minus y hat whole square sigma. So, what has happened? The total error is regression sum of square plus error sum of square. Okay. Here I want to predict the coefficient of determination. The coefficient of determination, referred as R square, is nothing but explained error divided by total error. What is explained error? Explained is nothing but SSR. That means that much error we are able to explain, because that much error is due to this independent variable x. What is the total error? This is SST, total sum of square. There is a two possibility of this R square. R square is, it cannot be more than 1. If it is 1, what is the meaning? The total SST, the numerator also SST, denominator also SST. So, what we are saying, this point, this line pass through that point. If it is less than 1, so what is happening? SS error is smaller, SST is bigger. Okay, equal to 1, both are same. So, the upper limit of the R square is 1, the lower limit is 0 to 1. So, 0 to 1 is the interval for R square. We will see this one. Yes. See a relationship among SST, SSR and SSE. So, SST, you see y minus y bar whole square sigma equal to SSR y hat minus y bar whole square sigma, for SSE y minus y hat whole square. You remember the previous also I was showing this SSYY, that SSY is nothing but sigma of y minus y bar whole square. So, this is a very handy formula if you are using calculator, and very shortcut, very quickly you can get the answer for what is SST, SSR and SSE. From that you can easily find out R square, nothing but SSR divided by SST. Yeah, R square is SSR divided by SST. SSR is sum of square due to regression, SST is total sum of square. You see that the previous also I was saying what is the meaning of this R square. So, we are getting in our problem we are getting 0.87. I will show you how it has come. Yes. The coefficient of determination formula is R square equal to SSR divided by SST. So, SSR in our problem is 100, SST is 114. So, I can show you this how we got SSR 100, you see that SSR. So, what is the formula for SSR? We have seen previously how we are getting SSR. You see that SSR is nothing but sigma of y cap minus y bar whole square. First we have to find out the regression equation. In that when you substitute first value of x, you will get y1 cap. Y1 cap is when substitute the value of x into that, then y minus y bar whole square. Then when you substitute x equal to 2, you will get y2 hat. So, then y bar whole square, when you sum that one, that is nothing but your SSR. SST is y minus, it is a numerator of that variance of y minus y bar whole square. So, from that you can find out SST. So, in this our problem it is 100 divided by 114. Now, what is the meaning of this R square? So, the meaning of R square is, as we know that it is 0 to 1, the regression relationship is very strong. What is the meaning is 88% of the variability in the number of cars sold can be explained by the linear relation between the number of TV ads and the number of cars sold. So, what is the meaning? That 87.7, 88% of the variability of y can be explained by the help of this independent variable. There is a remaining 13% that we are not able to explain. That may be due to two reasons. One is we might have missed that some other independent variable. There may be some other variable that affects the car sales. Another reason is that we have fixed linear regression. but the actual data may follow nonlinear regressions. So, that is why we are not getting exactly 1. In Python output you see that when you see the r square is the 0.77, this is r square is 0.77. That is the meaning of that is 87.7 percentage of the variability of cars sold can be explained with the help of number of TV ads, that is our independent variable. Okay. From r square we have to find out the r, that is a correlation coefficient. So, the sample correlation coefficient r x y equal to sin of b1. In our problem it is the sin of b1 is positive, root of coefficient of determination r square. So, sin of b1 into r square. So, what is this b1 is, that is slope of the regression equation. In our problem it is y equal to 10 plus 5x. So, the sin is plus, the root of 0.877 is, this is your correlation coefficient. And remember that the range of correlation coefficient is -1 to +1, but the range of r square is 0 to 1. Here in the correlation coefficient, if it is a -1 it is a perfectly negative correlation, if it is a +1 it is perfectly positive correlation, if it is 0 there is no correlation. In the context of r square, if it is 1 it is a perfect model, that means all variability of y can be explained with the help of independent variable. If it is 0 there is no relationship between x and y. The another important point is assumptions about the error term E. Here to test the goodness of the model, not only r square is important, you have to plot the error term. When you look at the error term, we have to look at the behavior of that error. Error is nothing but actual minus predicted value. So, what are the assumption of that error term? The error E is a random variable with mean equal to 0. So, the error has to be appear in a random manner where the sum of positive error should be equal to sum of negative error, so that sum will be 0. The variance of E denoted by E square is the same for all values of the independent variable. So, that concept called homoscedasticity. What is the meaning of that one is, if there are many x1, say x2, x3 independent variable, these variance of x1, variance of x2, variance of x3 should be same, then only there is a meaning for comparison. Otherwise, the variance of the error should be the same, then only there is a meaning for comparison. And the value of E is independent, another important. There should not be any pattern in the error term. Sometime what will happen, when you plot the error term, sometime there is an increasing trend, sometime there may be decreasing trend. This kind of pattern is not allowed. Error term has to be distributed randomly. And the another point is, the error E is normally distributed random variable. Now, testing for significance. So far, as I told you in the beginning of the class, whatever regression equations and the goodness of model which you have tested only for the sample data. What is the sample data? Y equal to B0 plus B1x. So, this capital Y equal to beta 0 plus beta 1x. Whatever we have done is only for the sample. Now, we are going to see whether this model is valid even at the population level. For that purpose, we are going to do some assumption. We will see what is that assumption, that is a hypothesis. To test for a significant regression relationship, we must conduct a hypothesis test to determine whether the value of beta 1 is 0. What will happen if the beta 1 is 0, there is no relation between x and y at the population level, but there is a possibility that there may be a relation between x and y at the sample data. It is not necessary that even at the population level there will be a relation between x and y. So, that testing can be done by two methods, one is a t-test, another one is f-test. Both t-test and f-test require an estimation of s square. S square is called the variance of the error, otherwise if you say s, it is the standard error, the variance of E in the regression model. What is the estimation of the standard error? Suppose in a normal data set, if there are two data set 1 and 2, one is having lesser variance than the other one. So, the first data set is more homogeneous. In the same way, when you do a regression model, suppose there are two models there, model 1 model 2. For the model in which there is a lesser standard error, that is a more suitable model. So, the mean square error provides the estimate of S square, and the notation S square is used. So, S square is nothing but MSE, mean squared error. We know that how we got MSE. MSE is SSE divided by n minus 2. Here what the degrees of freedom n minus 2. So, the logic is n minus 1 minus k, that is a logic of degrees of freedom. K is number of independent variable. In this we are having only one independent variable. We know that already the degrees of freedom is n minus 1. So, n minus 1 minus k will be n minus 2. And SSE also, you see that we can find out that formula which I in the beginning of the class which I am saying, y I minus y hat whole square. Okay. The y hat you can substitute b0, actually it is a b0 plus b1x. When you bring minus inside, b0 minus b0 minus b1x. The term s we make the square root of s square, the resulting is called standard error of the term. So, when you take the square root of this mean squared error, so you will get the standard error. See, in our problem, I will go back, I will see what is the standard error here, where it is standard error. As I told you, by using shortcut method you can use SSE divided by n minus 2. So, that is MSE. So, SSY minus SXY whole square divided by SXX divided by n minus 2, that is the standard error of the estimate. So, you have to take the square root of that, then you will get the standard error. Okay. Now, we will go for hypothesis testing. So, what is the hypothesis testing? Beta 1 equal to 0. That means that there is no relation between x and y. Alternative hypothesis is beta not equal to 0. The test statistic is B1 minus beta 1 divided by SB1. SB1 is the standard error for the coefficient of B. So, since beta 1 we are assuming 0, it is simply B1 divided by SB1. What is the meaning of B1 beta 1 equal to 0? That means there is no relation between x and y. If it is, when you plot the data, in this case hypothesis not rejected, it is accepted because beta 1 equal to 0. Now, what is happening? The beta 1 is not equal to 0, you see for this kind of data set. So, there is some relation between x and y. So, in this case the hypothesis is rejected. So, we are saying beta 1 not equal to 0. So, this is very important, how to find out the standard error of the coefficient of x, that is the B1. So, SB1 is SE, that is a standard error, divided by root of x minus x bar whole square. You see intuitively the total error, that is SE, then we are dividing how much error is due to this independent variable. So, total error divided by portions of error from independent variable x. So, that will give you SB1. What is the rejection rule? Reject H naught if the p value is less than or equal to alpha. We have seen many times this one. So, what will happen this one? If the p value is this say alpha, if the p value is less than that, you have to reject it, otherwise accept it. Where T alpha by 2 is the two tail test, because we are writing beta equal to 0, beta 1 equal to 0, beta not equal to 0. And when you look at the T table, you have to see n minus 2 degrees of freedom. So, first determine the hypothesis beta 1 equal to 0, beta 1 not equal to 0, specify the significant level alpha equal to 5%, select the test statistics B1 by SB1, state the rejection rule, reject H naught if the p value is less than or equal to 0.05, otherwise the T is greater than 3.182 when n minus 2 degrees of freedom. There are 5 data. So, 5 minus 2 is 3 degrees of freedom. So, this was the compute the value of the test statistics. So, 5 divided by the SB1 is 1.08, we get 4.63. Determine whether to reject H0 because T equal to 4.54 provides an area of 0.01 in the upper tile, hence the p value is less than, we will see how they got the p value less than 0.02. So, T is greater than 4.63, we can reject null hypothesis. When we reject null hypothesis, what we are concluding, there is a relation between x and y. This was the, here also beta 1 equal to 0 not equal to 0 two tile test, this is the right tile test, this is the left tile test. This was the formula for finding T, B1 minus beta 1 divided by SB. To find SB, root SE divided by, SE is standard error root of SSX, that is, this is the formula for SSE divided by n minus 2, SSX is sigma of x minus x bar whole square. Remember it is n minus 2 degrees of freedom. Next we can use the 95% confidence interval for beta 1 to test the hypothesis just used in the test. So, now with the help of confidence interval also we can decide whether null hypothesis should be accepted or rejected. H0 is rejected if the hypothesis value of B1 is not included in the confidence interval. Our B1 value what we are assuming it is 0. So, in that confidence interval if the 0 is appearing we have to accept null hypothesis, otherwise we have to reject null hypothesis. So, confidence interval for beta 1 is the form of confidence B1 plus or minus T alpha by 2 SB1, B1 which you got from our regression equation, that is the coefficient of x1, SB1 previously we are getting how to, I told you what is the formula for getting SB1. So, when you substitute it here, so what is getting B1 is 5 plus or minus T alpha by 2 is 3.182, SB1 is 1.08. So, 5 plus or minus 3.44. So, lower limit is 1.56, upper limit is 8.44. You see in that there is no zeros there. So, we have to reject null hypothesis. Conclusion, 0 is not included in the confidence interval. So, we are rejecting null hypothesis. The previous way we have used t test. Sometime what will happen if the number of independent variable is more than 2, we have to do the t test 2 times. If there are say 5 independent variable, you have to do 5 individual t test. As I told you, whenever you are comparing more than 2, you should go for ANOVA, that is F test. So, here also whenever there is a number of independent variables more, otherwise a generic method for testing the beta 1 equal to 0 hypothesis is going for F test. So, here F test is MSR divided by MSE. Even in ANOVA also, in ANOVA what we are trying to write in ANOVA, we write MS treatment divided by MSE. So, here MS treatment is nothing but our regression sum of square, mean regression sum of square. Okay. So, F equal to MSR divided by MSE. You see that MSR, how we are getting MSR, SSR divided by K. The K is number of degrees of freedom, that is nothing but number of independent variable. N minus K minus 1 is degrees of freedom for the error term. So, what is the rejection rule? Reject H0 if the p value is less than or equal to alpha, otherwise if the calculated F value is greater than the value which got from the table. So, F alpha is based on the F distribution. We have to look at the what is the degrees of freedom. If you look at say numerator degrees of freedom, in this problem we have only one independent variable. So, one degrees of freedom numerator. So, n minus 2 is 5 minus 2, 3 degrees of freedom for denominator. So, beta 1 equal to 0, beta not equal to 0, alpha equal to 0.05, F equal to MSR divided by MSE. So, p value we have to find out. So, numerator degrees of freedom is 1, denominator degrees of freedom is 3. So, that p value is 10.13. So, now we will use Python code, we will do that, import numpy as np, import matplotlib.pyplot as plt, import cburn as sns, import pandas as pd, import matplotlib as mpl, import statsmodel.formula.ap as sm, from sklearn.linear_model import linear regression, from scipy import stats. So, tb1 we are going to that regression data we are going to save in the object called tb1, and we are reading that. Now, what is happening? You see that the p value for the TV ad, we say alpha equal to 5%, it is less than 0.01. So, TV ad is a significant variable. If it is more than 5%, say if it is 0.06, the regression equation we will not include this independent variable TV ads. F statistics 21.43, I will go back, we will verify this answer. That we can find out MSR. How we do you remember, that is what I am saying that time. The first you have to find out SSR, regression sum of square. Regression sum of square is y hat minus y bar whole square sigma divided by k. K is number of independent variable, we will get MSR. So, the p value the f value is 21.43, and see the probability it is less than 0.01. So, that is less than 0.05. So, we are saying that the model as a whole, there are two things is there. As a whole model, the f value is less than 0.05, the model is valid, and if you want to check individual independent variable also. So, see here it is less than 0.05, so this variable is significant. See the lower limit, upper limit, there is no 0 here, 1.563, 8.43. So, we cannot accept, we have to reject null hypothesis. You see MSR is 21.43, we are here 21.43. So, we can verify that our Python result, then what we have done it with the help of manually. Some cautions about the interpretation of significant test is, so it is a very important this one, rejecting H naught B1 equal to beta 1 equal to 0 and concluding that the relationship between x and y is significant does not enable us to conclude that there is a cause and effect relationship in present between x and y. Just because of there is a correlation, we cannot say there is a cause and effect relationship. So, just because of we are able to reject H naught beta 1 equal to 0 and demonstrate statistical significance does not enable us to conclude that there is a linear relation between x and y. Dear students, in this class what we have seen, we have taken one sample problem, then we have fitted a regression equation. In that regression equation, we have gone for hypothesis testing, we have tested the significance of that independent variables. There are two ways to do the significance test, one is by using T method, T statistic method, another one is F test method. In both the method we have got the same answer. Then I have explained what is the meaning of coefficient of determination, that is R square. From the R square I have explained how we can get the R. The next class we will go for multiple regression equation, where we will consider more than one independent variable, and we will also explain some important assumptions in the regression equations. Thank you very much.